Okay, can you hear me? Yes, you can. Right, thank you, Morten, for taking us out into outer space. Now let's come back down to planet Earth. So my job in the next half an hour is to tell you what we've been doing for the last year, what we plan to do for the next year or so, and hopefully get you to the coffee break on time. Fortunately, we've got, as Morten mentioned, a really good program this year, so for a lot of the features that I'm going to mention today, rather than me try to tell you about them in great detail in this short slot, I'll just post you to talks later on in the program where the people more qualified than I will tell you about them instead. So I'm going to talk a bit about version 17.0, which was released this summer. I'm going to talk a bit about the next release or two that we've got coming up, and some other things that we're doing. Version 17 was released pretty much on our usual schedule in the summer, a few weeks later than usual, and had a collection of new features, large and small, which I'll go through quickly. Starting with small but important things. The error diagnostics in version 17, I hope you'll notice when you use it, have been improved so that the little caret you get, which has previously given you some incredibly vague indication of where your error might have been, now for the most part points at the function that caused the problem. And we've also, since Quad DMX was introduced, I don't know, 7, 8, 9 years ago, we've been working to improve that so that when you get an error, rather than say just file name error, you might get the name of the file and what exactly caused the problem. Hopefully that will make your daily programming lives a tiny bit easier. In the name of cross-platform portability, we've been working on portable file functions since I think they came in version 15. In version 17, we've increased the set of functions, so there's new functions for copying and moving files, and also those functions and a bunch of the existing ones have been improved so that you can operate on multiple files at a time. So, for example, you could copy or move either several files that you've named or a whole directory tree full of files. Also, Morten mentioned bracket link, which is to do with writing APL and keeping your source code in script files. Bracket link is a new user command that helps you synchronize APL's view of what source code you have and what files it lives in with the host operating system view. So, for example, if you're working in a local Git repository, the APL session wants to be running and using and perhaps editing the code that lives there, but you might also do a Git pull or use an external editor or something else that is going to modify those files. Bracket link is a tool that will help keep those two things synchronized, so it actually notifies the APL session when files have changed so that your APL can respond to that, and the same thing can happen in the other direction. If you edit files in the APL, hopefully your host tools will notice and keep the whole thing synchronized. And in a similar vein, to do with working with Git or working with at least modern version control systems, one of the problems that I know some customers have encountered is if you have more than one person working on your source code at the same time, the source code control systems tend to work well as long as you don't have two people modifying the same line of code at the same time. And a problem there is if you're working with traditional functions and you have a lot of local variables, you quite often find that any time you change the function, you end up modifying line 0, which could have, dozens of local names specified on it. The locals lines feature is a way of breaking up line 0 so that rather than specifying all of your locals on a very long line, you can split it up and have extra locals declared on line 1 or 2 or 3 of your function. And there's another new user command, bracket help, which is designed to... I've been told to stand in the glare. Bracket help is designed to fill in some of the gaps left by the F1 interactive help system. Bracket help is a user command that pulls together all kinds of help for different kinds of things you might want to know about, user commands and primitives and OO things and everything and brings them all together. Version 17 also brings some improvements to the HTML renderer component, which is something Morten didn't really touch on in his talk, as well as trying to make it easy to run services in the cloud, which mostly run headless, i.e. with no user interface. We also want to provide tools for doing cross-platform user interfaces that will run on desktop systems. Traditionally, that's usually been on Windows for us. But the HTML renderer GUI component is a cross-platform thing. And we've introduced improvements into that into version 17, mostly under the covers to try and make it more robust when you use it, for example, as a smaller part of a larger Quad WC GUI on Windows. I'll talk a little bit more about our future plans for that in a moment. And there was also a new, slightly experimental feature called APL as a shared library, which is, again, a slightly different model. Imagine you have a larger application that is not all written in APL. It could be in a whole bunch of languages, but you want to do some of your core calculation in APL. The APL as a shared library is about wrapping up the APL part of that in a way that can easily be called from other languages. Very similar to the way that you can create a .NET assembly on Windows to wrap up your APL code to look like a .NET component. This is taking it to a slightly lower level than that and wrapping up your APL code as a shared library that pretty much any other language on the planet can call into. So you can, as I say, wrap up APL calculations such that the rest of your application doesn't need to know or care that it's written in APL. It will just look like a library that can be called like any other. Along with version 17.0, we released RIDE 4.1, which had a bunch of work done under the covers to reintroduce support for floating editor windows, which I think were sorely missed when they disappeared from the previous version. We completely replaced the actual code editing component in RIDE in order to get much better performance if you're editing large scripts. For example, if you have a scripted namespace that runs to several thousand lines, the performance should now be a lot better on that. And we completely revamped the look and feel, and RIDE is now considered to be the default user interface on every platform except Windows, where we still have the classic IDE. And that's what RIDE 4.1 looks like. Now there's, I said there's a mishmash of new features. There were also some quite important changes to the language. The big new feature that went into version 17, which took a significant amount of design effort, is called total array ordering, which is extending the domain of the grade up and grade down primitives to include arbitrary nested arrays. Previously, since grade up and grade down were invented decades ago, you could only sort simple, flat numerical character data. We've extended this now so that you can sort nested data. In particular, you can do things like sorting a vector of character vectors, which is incredibly handy. Previously, you couldn't do it without resorting to some tricks like mixing your data. So that affects grade up and grade down, and it also works very nicely with the newish interval index primitive. And if you want to know more about that, I suggest you go and watch the webinar where this guy and Adam will try to explain all the nitty-gritty details and show you some use cases. And one more small extension, anyone who's in the workshop that we ran yesterday morning about performance will know we were talking about extending the set functions to work on higher ranked arrays. In version 17.0, we did that for unique. And as usual, we've done a lot of work on performance. In particular, in the last couple of years since Marshall Lockbaum has been working for us, he has been working pretty much full-time on performance. He has a lot of extremely good ideas. We tend to flash up these charts on the screen when we're talking about performance. We've been doing these for a few years. They're supposed to give you a kind of overview of how the performance has changed from one release to the next. And this is the chart we produced for version 17.0. Actually, it's become clear that for a couple of reasons, these charts give us a nice warm, fuzzy feeling when you see a lot of blue on the graph, but they don't actually give you a huge amount of detail. From looking at that, in fact, you have no idea what the things were that are sped up, and you also have no idea how far that blue tower on the left goes up. It goes way off the top of the graph, but how far? For version 17, so in addition to that graph, there's also a web page. You can find this just by Googling for Dyalog performance, I think, where we've got a write-up of exactly what kind of cases we've improved, what kind of improvement factors you can expect. So if you have any interest at all in exactly which kinds of code you can expect to run faster, or perhaps what new fast-performing algorithms you might want to try and take advantage of, I would suggest you at least take a look through this web page. And we'll try to do that for releases in the future as well. Try to describe in words what kind of thing we're working on for performance. So that was version 17. It was released in July. If you want to know more about this, I suggest you come to our workshop on Thursday afternoon, where we will show you some of these features and walk you through some examples and get you to try them out for yourself. On to the future. Gita mentioned already that we're planning more than one release ahead. Usually when I stand up here in September or October, I can tell you about what's coming up in the next release. Today I'm going to tell you about what's coming up in the next 2 releases. Our plans at the moment are to put out a version 17.1 earlier than normal next year. So that's going to be quite a shorter than usual development cycle for us. As well as that, we're planning to put out a version 18.0 at the usual kind of summertime slot the following year, in 2020. And the reason for this is that for version 17.1, we have a relatively modest list of features. It's really to do with completing some things that we hoped to complete in 17.0, which didn't quite make it, and tying up some related loose ends, trying to make especially some of the Docker-related stuff that Morten's been talking about work a lot more smoothly. Whereas version 18.0, because we're already starting to plan and implement stuff for 18.0 now, it gives us a much longer runway before release, and we're trying to plan some really ambitious new projects for 18. And the important thing about this is that these 2 releases are both being developed right now. We're developing them concurrently. So it gives us a long time to plan and implement some of the big projects we want to do for version 18. So 17.1 first, which should be released earlier than usual next year. The kind of defining features for this are to really get the HTML renderer working properly on all platforms. This was a goal for version 17.0 that we were close to achieving, but there are technical reasons why it turned out to be difficult, in particular to get this working nicely on the Linux desktop. Version 17.1 should have all of that sorted out so that the HTML renderer works on all of our desktop platforms, which is Windows, the Mac, Linux, and I'm not sure about Raspberry Pi, actually. Windows, Linux, and the Mac, let's say. And the other thing we'd like to do for version 17.1 in particular is to get better support for running APL in headless mode. That is, running it in a Docker container, running it in the cloud where there is no user interface. Now, Morten's shown demos of this already, so it does work. There's a workshop, I think, on Thursday afternoon concentrating on this, so you can see for yourself that it does work. You may also see that there are a few rough edges and things that don't work quite as, it's not quite out of the box. It doesn't work quite as straightforwardly as it should, partly to do with running the APL headless in the first place, and partly to do with connecting RIDE to it and getting that up and running really easily. So we hope to sort out all of those rough edges and tie up those loose ends. Of course, we can't stop ourselves doing a little bit more than that, so also for version 17.1, I think we need to do some work on the packaging, especially for Linux, which I'll mention in a second, and all of the sort of usual day-to-day minor bug fixing, minor new features and performance work. We're not going to try and hold that off for version 18.0. That stuff will go into version 17.1 as well as usual. Now, I mentioned we wanted to tweak the packaging a bit. We've said today that if you're running in the cloud and using Docker, typically that all happens on Linux. You can run Windows images in the cloud, but if you want to run a full version of Windows in a cloud image, typically the image size is, 6 gigabytes. Microsoft have something called Nano Server, which is a drastically cut down version of Windows, which comes in at under 0.5 gigabyte. Whereas at the other end of the scale, if you run on a completely minimalist Linux distribution that's kind of custom built for running in the cloud, you can get images as small as 2 megabytes. So sitting in the middle there are Dyalog APL installations. Now, the two things I said we wanted to do for version 17.1 are get the HTML renderer working and concentrate on Docker support. Now, there's a bit of tension there because the HTML renderer is based on the Chromium framework, and once you bring that into a Dyalog installation, it bumps up our installation size by well over 100 megabytes. Conversely, if you're running in the cloud, you want to try and keep things as small as possible. So once we have sorted out the licensing issues to make it easy to install or to get hold of APL for Linux, the next thing I think we need to do is to sort out some packaging issues to make it easy to decide which parts of the installation you want. So in particular, it should be easy to get a minimal installation that doesn't include the HTML renderer and other things that you only need on a desktop system, and it should be easy to get the full desktop installation if that's what you want to run on your development system. And following on from that, we are probably going to have to bump our minimum version requirements for Linux. I can tell you more about that if you're interested, but I'm already running short of time. Performance, I will come back to. So, onto the exciting stuff is the version 18 release, which is scheduled for summer 2020. Now, what I'm going to tell you now are our plans and ideas for some of the big projects that we want to tackle in version 18. These are not promises. Many of them have not been fully designed or planned yet. Pretty much the only thing I can promise you is we probably won't get all of them finished to our satisfaction in time for version 18. This is really to whet your appetite and tell you the kind of thing, the big things that we would like to tackle. And they don't come much bigger than everything. First thing I want to mention is the theory of everything. I'm not going to say too much about this because John Daintree will be explaining it in detail tomorrow morning. Just to try and say what it is in a sentence, it's an internal object model for Dyalog APL. It's a way of exposing to the user metadata about what's going on inside your APL system and the system itself and the environment you're running in a kind of structured way. It can do a lot of cool stuff, and I'm sure John will show many of them tomorrow. The next one, this is kind of, in some ways, just a technical detail. Dyalog APL, I think since day one, has restricted the maximum rank of an array to 15. Now, most of you, I would guess, don't generally run into that limitation, but we do have some customers for whom it is a serious problem. They're running into the limit. Life is getting more painful for them year on year, and they're seriously considering switching to R or MATLAB or something for parts of their calculation because they simply can't do it in APL anymore. We would like to lift this limitation. The downside is that this is going to be one of the most invasive changes we've made to the core of the interpreter for a long time. And it also affects the backwards compatibility story. So we take backwards compatibility very seriously. You can load old workspaces. Workspaces are kind of binary images of what goes on in the interpreter. You can save in one version of APL, and you can load it into a different version of APL. Anytime we change the data structures in there, we have some work to do to kind of fix up the differences and bring it up to the modern standard. Increasing the maximum rank of an array involves changing those structures in a very fundamental way. It also will affect the structure of components on component files. Another thing you've always been able to do with Dyalog APL is write simple array data to a component file in one version and read it back in a different version, whether that be a later version or an earlier version. Now, we certainly don't want to break that model. We have a lot of work to do to work out how to do this without affecting that experience. It's possible, depending on how we do this, that we may need to patch older versions of the interpreter so that they're able to cope with simple array data that was written by newer versions, but that hasn't been completely decided yet. The end result of this should simply be that you can create arrays of much higher rank, perhaps up to 64 or whatever seems to make sense. And there are a bunch of other limitations that we should address at the same time. For example, sometimes people execute very long strings of numbers in order to import data, and you run into limitations there. Like, I don't think you can have more than 4,000 constants in a string that's executed or in a defined function. Skip that. I shouldn't skip a slide that's got a warning symbol on it. This is, Geeta mentioned that we put a lot of effort into preserving backwards compatibility, and it sucks up a lot of our resources. It actually makes us less productive because we have so much work to do to make sure that we maintain binary compatibility with old versions of the interpreter. One of the things we would like to do, if we can, is to remove the ability to load a workspace when you're in the middle of running your code that was saved by an older version. So at the moment, you can run some code in version 12, I don't know, you can trace into some functions, and you can save the workspace at that point, perhaps with a quad save, and then you can load it into a later version and resume with the SI stack intact. I don't think that's a good thing to use operationally as part of your application deployment. It causes us significant problems to carry on supporting it. And I would like to remove that facility. If you think that might cause you problems, for example, if your application deployment does depend on quad saving a workspace with a stack and then quad loading it later, come and talk to us and we'll talk about it and we can advise you. .NET Core Bridge, Morten spoke about. Currently on Windows we have a .NET bridge. .NET Core, although it shares most of its name with .NET, is actually a complete re-implementation done by Microsoft of a .NET-like thing. It's open source, it's cross-platform. I think it runs on at least Windows, Linux, and Mac. If you are into running Windows images in the cloud, you're probably looking at using Windows Nano Server, which only supports .NET Core. It does not support the classic .NET. The downside is, because it's a complete re-implementation, it's actually a significant amount of work for us to create a bridge to .NET Core that will give you the same kind of functionality that the current .NET bridge on Windows gives you. But I think it's important. It will allow support for headless Windows operation, and it will give us access to APIs on Linux and Mac in a way that we've never really had before on those platforms. Array notation, getting onto more languagey issues. You have probably seen Adam speaking before about his ideas for a literal notation for arrays. The way I like to explain this is it does for high-rank arrays what strand notation does for vectors. So it just gives you a way of constructing higher-ranked arrays in your APL code in a more declarative fashion. You can just write them as opposed to having to use a lot of primitive operations to construct them. And that has big implications for storing your code and your data in text files. Adam will be talking about that straight after the break. Another big idea, magic arrays. I don't think we've spoken about this publicly before, but it's an idea that has been floating around for a few years. Dyalog APL itself doesn't have a way of representing a sparse array. It doesn't have built-in support for inverted arrays or, tables stored as vectors of column vectors. If you want to use those at the moment, you have to change your APL code to, rewrite your APL code to work on those forms explicitly. The magic arrays idea is a way of you or a sufficiently advanced APL programmer writing some APL code that is a description of what you want the internal representation of your array to look like. The magic part is that having created one of these things, one of these arrays in your user-defined format, you can wave a wand or wave an I-beam or something, and from that point on, that thing will appear to the rest of your APL code just as a normal array. So for example, if you have 1 million lines of business logic that is already working on matrices, you will not need to rewrite that code. It thinks it's working on a matrix. Under the covers, it might be working on inverted tables or something. And the magic, the clever APL that you have to write is, this syntax is by no means finalized, this is just a sketch, but perhaps you'll have to define something that looks a bit like a class and tells the interpreter how to implement any primitive functions that you're interested in on your particular chosen representation. So we think this will be useful for sparse array representations and for inverted tables. I suspect it will be useful for hundreds of other things that we haven't even thought about yet. I think I'm probably out of time now, yes. We're in no rush to implement new primitives and new operators, but there are a few forms of composition that I think we should probably think very seriously about putting into version 18. Under, I think we've spoken about before, over is even simpler and very closely related. I won't explain those now. We have ideas for allowing you to write config files that describe a configuration of the interpreter and an application. So currently, if you want to configure your interpreter, you typically do that by putting things in the Windows registry or in environment variables or on the command line, and those systems are different between Windows and Linux. The idea of having a config file is it will be a cross-platform way of specifying these kind of things that you can easily package up with your application that says how to run the interpreter for your application. You can easily share it between different interpreter versions when you're upgrading, and you can easily share it across platforms. And as Morten mentioned at the end of his presentation, we want much better support for executable scripts. We've been pushing for you to store your source code in text files for a long time. We also want to make it very easy to run your code or your application directly from text files. So those are the things that the big ideas that we're trying to work on for version 18. What else are we doing? We're working on Ride. To be honest, there isn't a huge amount of new functionality we have planned for Ride. Morten also showed VS Code integration. The reason I mention those two is that they share a lot of the same technologies, and Gil will be telling us about that this afternoon. So I'll leave that to him. Gil will also be talking about package management tomorrow morning. And we are always working on performance. We have this year, I think, 3 talks concentrating on performance. Marshall is going to talk about some very cool, very fast implementations of set functions. Roger is going to talk about the wonders of inverted tables. And Marshall's going to try to explain how it is that interpreters can sometimes have the performance edge over compiled languages. Co-defense development is continuing. Aaron will tell us about that from the inside this afternoon. And we have Eric Wallace later in the week who'll tell us about that from the outside as a user of co-defense. And even good old defense themselves are still getting some love these days. I'm pleased to say that John Skulls has done some serious development work on the implementation of defense, which I think he might mention on Wednesday morning. In summary, I'm out of time. Coming up, version 17.1 due out early next year, 18.0 due out in its usual slot in 2020. Thank you.